Hey guys, so for today's video, let's talk about solid phase peptide synthesis. So in laboratory setting, proteins are usually produced by bacteria in which they express certain proteins. So scientists can actually engineer the gene of the bacteria, or they can insert certain plasmids into this bacteria to produce desired proteins. Actually, this is so good because this bacteria can actually produce a lot of proteins, or you can scale up the production of protein depending on whatever amount you need. However, the disadvantages of this include in some cases, this bacteria cannot produce your desired protein. So, also, some proteins, such as PTMs or post translationally modified proteins, cannot be produced by bacteria. And these PTMs are actually very important in the studies of Alzheimer diseases and other neurological diseases. That is why solid phase peptide synthesis come into the scenario. So, what is solid phase peptide synthesis? So, this is actually a technique usually used in protein chemistry where your first amino acid or your peptide is actually bound into the raceme, which is consist of an amino group, and your first amino acid is added to this, and this raceme actually serves as a support into which you can carry out your solid phase peptide synthesis, and it follows the basic steps such as the deprotection of the raceme. So when you deprotect the raceme, it exposes its amino group, which then if you add your first amino acid and you activate it, you can actually form a coupling reaction, and then you can see that your amino acid is now bound into the raceme. And if you follow the next steps and then you continue to do the deprotection and you continue the cycle, you can actually form a longer peptide. And after that, you can cleave the protecting groups into your peptides, and you can obtain your desired peptide. So let's explain further about these steps. So the steps are actually very easy and it's very simple to follow if you are in the laboratory. So the components of the solid phase peptide synthesis includes the raceme. So as what we have mentioned before, this raceme acts as a support of our synthesis, and then this raceme has a linker bound to it, and this linker actually connects your raceme and your first amino acid, and then it's followed by the amino acid residue and the side chain protection group. As what you have known before, or in the basic knowledge, this amino acid actually contains side chain, and in order to avoid the unwanted reactions, we add, or there's usually a side chain protection group added to the amino acid and the main chain protection group, and this is usually an FMO, which allows the subsequent addition of amino acid one by one. So let's explain further. So first, you have a raceme, which is a support followed by a linker. So why is this raceme important? So imagine you're carrying out a reaction in a peptide synthesis tube, and this tube usually has a hole here where your liquid comes out after you wash your protein. So when your raceme is here, it's actually inside a tube, and then you add your first amino acid, and in coupling reaction your first amino acid will be bound here in the raceme, and then after the coupling reaction you can wash it with certain solvent, and the excess reagents will actually be washed away, and then you can carry out the next steps. So without this raceme, your peptides will be washed away. So this raceme is actually a support in order for your peptide to be attached and be inside this tube. So this linker usually is pre-equipped into the raceme, and it consists of the amino group. And when you add your first amino acid, it usually has the carboxyl group here, and via the condensation reaction you're going to couple them together into the linker and the racine. So you're gonna form your racine, linker, and your first amino acid, which has the FMOC protection group. So the next step that you may do is to remove this FMOC via FMOC the protection using like 20% piperidine in DMF. And the addition of FMOC group actually exposes the amino group of the amino acid. And then you can add the next amino acid, which has the carboxyl group here. And then via the same reaction, the condensation reaction, you're going to form a dipeptide. So you can continue the step. Next step is you're gonna deprotect again, which exposes the amino group, and then you can add your next amino acid to form a tripeptide, and then you can just continue doing that until you get your desired peptide. And after you obtain your desired sequence, you can remove the protecting group, which is usually an FMOC, and then you can also remove the side chain protection group. And then this will be your final peptide. You can try like different methods. There are a lot of methods to do that. Like you have this peptide and you have several peptides, and if you want to form a protein, you can actually combine them together and then you can get a bigger protein. So, yeah, so this is the steps on how to carry out the solid phase peptide synthesis. So, thanks for watching my video. I hope you'll have a good day. Bye.